an air core solenoid with length of 30 centimeter, length 30 centimeter, it means how much meter? 0.3 meter. Area of cross section 25 centimeter square, means it is 25 into 10 to the power minus 4 meter square, and number of turns 500. See here, number of turns they are 500, and therefore number of turns per meter, small n is equal to n by L, that is equal to 500 divided by, what is the length of solenoid? 0.3. It is per meter, carries a current of I equal to 2.5 ampere. The current suddenly switched off for a brief time of 10 to the power. Current suddenly switched off for a brief time of time t equal to 10 to the power minus 3 seconds. How much is the average back EMF induced? How much is the average back EMF induced across the ends of open switch in this circuit? Now ignore the variation of magnetic field near the ends of solenoid. Ignore the variation of magnetic field near the ends of solenoid. Now remember that the self-inductance of solenoid is given by L is equal to mu 0 n square L into A. Mu 0 n square L into A. Also we know that EMF induced E is equal to d phi by dt. E is equal to what? D phi by dt. But flux phi is equal to L into I. Phi is equal to what? L into I. So this is the d dt of L into I. L is constant, take it outside. L into di by dt. L into what? Di by dt. But what is L? L is equal to mu 0 n square L A. Mu 0 n square L A into that di by dt. Di by dt. So EMF induced, back EMF induced is equal to mu 0. What is mu 0? 4 pi into 10 to the power minus 7 into n square, number of turns per meter. So it is 500 divided by 0.3. 500 divided by 0.3 whole square into length of wire 0.3. Length of wire is what? Length of solenoid is what? 0.3 meter. Into area of cross section, it is 25 into 10 to the power minus 4 meter square. Minus 4 meter square into. Now di by dt. Di by dt means change in current. See here. Initial current is 2.5 and finally it becomes 0. So it is 2.5, it is di upon dt. What is the time required for it? It is 10 raised to minus 3. It is 10 raised to minus 3. And if you simplify it, then the back EMF E is found to be 6.5 volt. Back EMF E is equal to 6.5 volt. So option A is the correct option for this question.